Howdy doody, fellow students. How are we doing? What's up? How are we going? All right, so we are going to be solving linear equations. Very, very exciting things. Lots going to be going on. If you ever need to pause the video, you can just go ahead and pause it and figure stuff out as I go on and explain it. All right, solving linear equations. Here we go. Number 1, 5x minus 9 is equal to 21. Well, we got to get that mean all x by itself, so we are going to add 9. Get rid of that, which means we're going to add 9 over to 21, which will leave us with 5x is equal to 30. And then we're going to divide 5 because 5 is right up against the x, which is multiplication. Get rid of that, divide that out. You can leave it as 30 over 5, or you can do commonly known as x is equal to 6. How you like them apples? All right. Fairly basic, not too complicated or brain-racking. Well, maybe it might be, I don't know. All right, so negative 8x plus 3 is equal to 12. Well, we want to get that pesky x by itself, so we are going to subtract 3 to get rid of it, which means we also subtract 3 here, which is negative 8x, which is equal to 9. And then we are going to divide by that negative 8. Getting rid of that. Going to divide by a negative 8. The answer will be 9 is over negative 8, or x is equal to 9 over negative 8. Or you can put it out in decimal form, which is negative 1.125. All right, so fairly basic stuff, a little bit of review. Review's always good. Keeps you remembering what you remembered. All right, so 54 is equal to 7 parentheses x minus 4. All right, so what I like to call this is math trickery. So they like to throw that equal sign on the left side to make you believe that it is a completely different problem, when in reality it's no different from putting the equal sign on the other side. So math trickery is what I call it. Okay, so you're going to multiply 7 times x and then 7 times negative 4. So it'll be 54 is equal to 7x minus 28. Then we plus 28, or add 28 to get rid of it. Get out of there. And then we add 28 over here. And then that will add out to 82 is equal to 7x. We divide by 7 to get rid of that 7, which means we also divide 82 by 7, which will leave you with 82 over 7 is the answer. X equals 82 over 7. You're pretty basic. All right. So number 4. Number 4 can be a little bit tricky because you may want to, just out of habit or fun, want to add 2 plus 3 first right here. Don't do that. You want to do the the distributive property first and do 3x minus 2, which is 6. So 3x minus 6 is what it's going to be. So we'll write that out as 2 plus 3x minus 6 is equal to 21 plus 3x. All right. See, now we can combine like terms. So, 6 and negative 2. Or, I'm sorry, negative 6 and 2. Sorry. So, negative 6, 5, 4. So that would be 3x minus 4 is equal to 21 plus 3x. Excellent. Then we add 4 to get rid of that 4. X is equal to 25 plus 3x. All right, so initially what you're going to want to do is you're going to want to divide that 3x to get rid of it. But a little rule for you, when all you have is addition and subtraction left, you add and subtract. Very important. When all you have is addition and subtraction left, that is what you do. So there's nothing left but addition and subtraction left. So what we're going to do is we're going to subtract that 3x. Subtract that 3x to get rid of it. And then we're going to subtract that 3x over here. And of course, those cancel each other out. So our answer is going to be 0 is equal to 25. Hold on a second. That can't be right. Well, actually, it is correct. See, it's kind of tricky because this problem has no solution. No solution. Let me explain. So, say for example, you have a scale. Okay? You have a scale. So you have 3x. So we have 3 boxes of x. And we have no idea what's in them. 3 boxes of x. We also have 3 boxes of x on this side of the equal sign. So I'll put the equal sign over here. But you also have this plus 25 over here. So in a way, these will never be equal because this plus 25 is always going to be on this side. So it's always going to be an unequal equation. See, in math, we're in the business of balancing equations. So that's basically what we're doing. And because of that plus 25 right there, we can't balance the equation. So for 4, there would be no solution to number 4 because 0 most certainly does not equal 25 in any way, shape, or form. Very tricky. Always look out for things like that. All right, very excellent. So we have got 10 minus 4x plus 3 plus 3x is equal to 7 plus 2x. Ooh, it's one of those hairy problems. Okay. So all we have got here is a very hairy problem. There's no need to panic, nothing to panic about. I lied to you. I apologize. This is not the one that we're doing. Not the one that we're doing. Sorry about that. All right, so what we're actually doing is 9 minus x plus, let's see, 4 is equal to 12. There we go. That makes way more sense. All right. Disregard that number 5. It's a lie. Okay, so you have to remember that when you just see a negative up here, that's the same as a -1. It's the same as a -1. So what that's going to do is that's going to even out to 9 minus x. 9 minus x minus 4 is equal to 12. Okay. And then what we're going to do is we're going to combine like terms. So 9, 8, 7, 6, 5. So my negative x, and then that's a plus 5 is equal to 12. And we're going to minus 5, which is negative x equal to 7. All right, so we can't have a negative x right there, so what we're going to do is we're going to throw that negative right over here. Throw that negative right over here. So the answer is actually x is equal to negative 7. All right, thank you so much for listening. As a reward, I'm going to recite a poem about math. I often wonder of a time when a poem about math could have rhyme, and all the children in the land will shout and say, hey, equations aren't so bad. And all of those tricky graphs will be solvable. Then maybe in class you won't feel so gullible. Your teachers and parents will say, oh, we're so proud. And you will be astounded by the new power and your new ground. Well, I'm not the greatest poetry reciter on the planet, but I thought that was a pretty good math poem. Thank you so much for listening, ladies and gentlemen. It's been fun.